one of my most favorite things, which is talking about concrete and colloidal silica. We've got a question from DEYC3. David, thank you for another amazing question. And David just really inundates us with some of the best concrete colloidal silica questions out there. And really we need to send you some lucky concrete, man. Like, thank you so much. Anyway, ding! So, wait, Ag SSD with colloidal silica? Is there anything that you can't do with this stuff? It seems to be the best way to save the world with all the concrete in it. What a wonderful line. To drive the cost of colloidal silica. How do we do that? So there are, I think, like 3 questions in there. So the first one was, we had this whole video on high absorption aggregate and using colloidal silica. And that's actually a teaser into one of the talks or webinars that we're going to give on recycled concrete, aggregate concrete, and using colloidal silica to use one of the biggest obstacles with RCAC to make concrete stronger and last longer, and used waste material. So there's a reason why, and David, thank you for walking into that trap. But yeah, a high absorption aggregate, whether it's a soft limestone, it's an RCA, you have that high absorption, you have those capillaries, or that pore structure developed into the aggregate. You can almost use that as an internally cured concrete material. That being said, by doing a initial mix with colloidal silica and that dry aggregate, you can get that colloidal silica into the aggregate, and not only are you going to have that water in there, but you're also going to have that colloidal silica. And what we've seen is it reduces the monopolization of water into that high porous aggregate, and also helps stabilize air content, but then it also helps reduce shrinkage and increase strength, especially the bonding that we see at the failure of the aggregate. Okay, so that's the first question. So the second thing was, Haley has very young eyes compared to mine, so I have to take my glasses off. So, I can barely see this. It's awesome. Is there anything that you can't do with this stuff? Yes. I love colloidal silica. Colloidal silica is how I made my name in the industry, and it at one point where I didn't love concrete as much as I love it today, it helped me get excited about concrete again. So it really was my Richard P. Feynman of the quantum physics, but for the concrete side. So it got the whole cafeteria trade that he threw, and he saw the whole angular velocity, and it got him excited about physics again. It's in the book Surely You're Joking, Mr. Feynman. Excellent book. We'll put a link below. But as we digress, there are some things that colloidal silica can't do. For the first thing, it can't replace cement like our more mature technologies. And what I mean by that is it does become cost prohibitive, but also it makes the mix sticky and nasty when you start going above 3%, 4%, even with the much larger particles, which theoretically you can go up to about 11% replacement of your Portland cement with those larger particles. It's just the mix becomes very hard to manage. And then you got to use like a fire hose dispenser to get that much admixture into the truck. Because remember, colloidal silica is a liquid dispersion, so we can't go to those percentages. And then, the other thing is it really can't do all this stuff alone. And that's one of the things that does frustrate me, not your question, David, but frustrates me throughout the industry. Like whenever a new technology comes in, that new technology has to do everything. Like it has to take the place of this, that, and the other. When we should be using a wide gamut of tools, whether that's tools as in, a wrench or a hammer, or tools as in our fly ash or silica fume, metakaolin, high range, mid range, normal range. I mean, there's so many additives and admixtures out there that we can use to make that concrete stronger and last longer, so we can effectively save the world with all the concrete in it. Okay, and then the last piece to that is, how do we drive the cost down? And colloidal silica is actually not that expensive. I mean, the really cheap, grody stuff is around $5 a gallon. The small particles, or small particle size distributions, 3 to 5 nanometers, they're easier to make. The wide distributions, they're really easy to make. So those will be somewhere around $15 per gallon. But you're only using 1 ounce to 4 ounces per hundredweight of this stuff. So if you're using 1 ounce per hundredweight and you have 600 pounds of total cementitious, that means you're using about 6 ounces per cubic yard, which, what's 6 ounces what's 6 ounces divided by 128 of a gallon? That's like barely anything of a gallon. It's, not that much of a cost. And when you do start getting up to, let's say 6 ounces per hundredweight, because you can go a little bit higher. So let's say you go 10 ounces per hundredweight, you have 6 hundredweights per cubic yard. So now you're talking about 60 fluid ounces per cubic yard, which is around half a gallon. So half a gallon, it costs $7 per gallon. Now you have an incremental cost of $3.50 per cubic yard. Okay, that does have a cost to it, but when we're talking about making concrete stronger and last longer, we're talking about not ripping and stripping our concrete out at 6 years, but at 12 years, or at 20 years, or maybe even 40 years. So what's less expensive? The additional cost, or what's more expensive? The additional cost of the product to the concrete, or ripping out the concrete prematurely, especially if you have like a 15-year warranty? I mean, that's going to cost you a lot of money, and especially if you're putting it on your insurance company, that might give you some problems getting insurance on into the future. So anything that we could do to make that concrete stronger and last longer is great, especially because we are playing with the cost long-term wise. So, I mean, I get it that it does cost, but all good things do come with a cost to it. So that's the only one that I can't answer in the way that you might want that answer. But that being said, I guess I should lead it off or close it off with, we have done some work with colloidal silica where we have increased the cement efficiency. Back in 2003, 2004, Bjorn Bjornstrom wrote a wonderful set of papers on accelerated cementitious dilution of A-lite and B-lite, or tricalcium and dicalcium silicate. As a matter of fact, in our Concrete International paper published in 2014 or 15 on colloidal silica admixtures, we showed an increase in cementitious efficiency, which meant that you could reduce the total cementitious to achieve the same compressive strengths, and we're not seeing a major change in the workability because colloidal silica, per Konstantin Sobolev at University of Wisconsin, has shown that colloidal silica does help enhance high-range water reducers to get you more bang out of your high-range water reducer buck. So a lot of information, a lot of great questions. Thanks for your time. Go concrete! Get asphalt!